Hey everyone, welcome to the Kubernetes show. My name is Hardeep, and we are picking up from where we left last week. Last week, we installed a 3 node cluster. If I show you, you go to the repository, you can look at these first 3 links. They talk about everything that we did last week. And in the third one, you'll see details on how we install that cluster. Again, there is a link to the video that I uh, created last week, and that should give you a good starting point. All right, now we have a working cluster. We talked about all these things, but today's topic is picking up from where we started and uh, getting a bit deeper into another important topic, which is on the minds of many people who are trying to learn Kubernetes, which is Certified Kubernetes Administrator exam. I decided to use this one as a topic because uh, CKA exam covers many beginner level tasks that you need to do when you have a kind of Kubernetes cluster. And exam also gives you a real world hands-on experience, and it is kind of validating your skills as well. Again, you don't need to give the exam to learn what I'm kind of sharing here, but this is where I wanted to kind of give you some idea about what it is, what CKA exam is. But from the learning point of view, we'll get into it within a moment. There are in this exam, 25% of is covered for cluster architecture, installation, and configuration. So it is total 100%. Out of the 100%, 25% is cluster architecture, installation, and configuration. Workload scheduling is 15%. Service and networking 20%, storage 10%, troubleshooting 30%. Now, what what are these things, and how do you get this 25%, for example, right? I have included some links here, and all these are thanks to Mr. Chad. It is his repository. I'm linking all his content here, and he wrote a book also on this, acing the certified Kubernetes certified administrator exam. So if you are interested in going for the exam, you should go and read this book as well. But if you don't want to read the book, you don't want to spend money, I think we'll be using this channel to prepare you for the exam using all the documentation that is available here. There are some links provided. One is directly for the Kubernetes CK exam curriculum. If you go in the curriculum, this is the CNCF repository. If you see, it says github.com CNCF curriculum, and inside that you can see 10% is storage, and it talks about in detail like what in storage they are looking for. 30% troubleshooting, workload, cluster architecture. I'm going to start from cluster architecture, installation, and configuration because I want you to get hands-on experience before you go little kind of into little deeper into it and start working on some advanced topics. All right, with that, let's start and let's take a look at what else we have. Okay, there is a link that takes you to Linux Foundation, and it tells you how much is the exam cost and all. You have some Kubernetes lab environment. All these kind of hands-on environments, exam like scenarios, are available on Kilkuda. This is also a link to Chad's repository. So if you kind of click on it, and you open it, you can see it is taking you to killer slash chad m cromwell, right? So you can click on this and start the kind of scenarios, right? But before we kind of get ahead of ourselves and start looking at the scenarios, I think first we need to understand very basic constructs of Kubernetes. And to do that, I'll take you to the Kubernetes documentation. All right. Again, this might look something, you know, very advanced level, where you have too many clusters, you need to make too many changes, fix things, update. But as you work with me on these videos, you will be able to do these things very easily in your own environment. All right, with that, I'll get into very first thing, which says cluster architecture and installation. If I click on it, it takes me to Chad's repository, where it talks about few things. But before I get into this repository and start kind of following the steps that are listed here, I wanted you to have a little bit of understanding of how does this exam work. During the exam, you'll have access to this page which says kubernetes.io/docs. I think they allow blogs too on the same, but you can have one tab open at a time. And so once you land on this page, because the time is so limited and this exam is hands on, there is a good possibility that during the exam time you have 17 questions and you'll run out of time. uh, why? Because we get so lost into, while we are troubleshooting something or trying to implement something, we don't look at time. So time is very important. One way to save time is knowing the documentation better. So how do you know the documentation, right? You go on Kubernetes website, kubernetes.io. So let's do this. So kubernetes.io, you land on page like this, click on documentation. Inside documentation, there are many details here. Now, very first thing you do is go to this kubectl quick reference. You can do it from here, or you can go from some of these, like it says references. Then from here, you can look at this command line tool, kubectl, then quick references, right? You need to know where to go and look for a particular uh, reference. Let's take a look at what is this quick references, right? uh, if you are typing kubectl multiple times during the exam, it's gonna take few seconds away from you, which you could use to kind of uh, work on solving the problem rather than typing kubectl. In exam, you are provided with these aliases, but if these don't work, you can literally come into, click on documentation on this page, scroll down, click on kubectl quick reference, right? Take these, put them into your bash rc source, and you should be good, right? So this source is doing on the fly. This ensures when you open a new session, your autocomplete is available. This is setting up an alias for it. So it depends on what shell you are using, right? And next thing is knowing your Kubernetes config file. Now, what is Kubernetes config file? Kubernetes config file is what tells you what is the username that connects to a cluster, what clusters are there that your kubectl command can act against, or what clusters you can connect to, what users are available. All those things you define. This tilde.cube is directory within your home directory. Tilde is home, dot is a hidden directory. So go into tilde. Let's see, if we do this, you can see there is something called config. So if I do this and say config, you can see, it is showing me my VM user cert and, some details of it. But I can do this also, because I have done K, right? K config view. So if I do K config view, you can see it is showing me all the data hyphen hyphen. If I do raw, basically it is as good as doing cat to that file. If I scroll up and I show you, this is what I ran earlier, cat cube config, and next I ran k config view, then I did k config view raw. Raw is as good as doing cat to this file. By default, it doesn't show a raw. It basically says redacted or omitted. You can see data omitted, right? It is not showing those certificates. Anyways, uh, so one way to configure your clusters and communication to those clusters is using this file, um, and this is the default location of the file, right? The home directory dot cube and config. But if you don't want to make changes to this file, you can use a environment variable named kubeconfig, and here you go, you can define a file and you can say, multiple files. Basically it is using merged view of both, right? So if you don't want to see a merged view, you can literally say kubeconfig and give path to a kubeconfig file, and your uh, kubectl command will start to follow that particular kube config, right? So not going into much details into it, I wanted to give you a little bit of idea about how does kube config work. Let's say you are in exam and you forget what command to run, right? So either you do full kubectl or you do k, then say config space help, right? So now it says kubectl config and help. All right, let's see, config hyphen h. All right, hyphen help rather than help. All right, so hyphen h gives us similar things. And if I say I don't even know, what options are available after view, I can say view hyphen help. You can see it gives me bit more details. Another interesting thing it gives me is examples, right? So during the exam, if you forget what command to run, you can literally run this command with the hyphen help or hyphen h, and you will have access to uh, all the things that you need. For example, you forgot how to maybe set up the autocomplete, right? You can say kubectl options, and if you scroll up, I think it was, hold on, it was autocomplete, I think. Completion, sorry. Yeah, it was completion. So you can say completion again hyphen h, then it is telling you, for example, for fish you do this, for ksh you do it like this. All right, so enough of these, and I think you got the idea, mm, how you can see help, right? Let's take a look at very first thing that you're going to deploy in your Kubernetes cluster, which is pod. Again, I'm going back to what this 25% covers. It says your cluster architecture. We talked about cluster architecture a little bit during my previous video. Installation, we already have done it. Configurations, will get into it, right? So it is 25%. But anyways, we will get into the pod. Just before I do that, I wanted to kind of show you what Chad has listed on his website. He shows the same things that we were looking at. Again, during the exam, you'll not have access to this GitHub repo or my GitHub repo. What you'll have is this kubernetes.io website, and if you know where to go and look for documentation, you'll be able to succeed. Anyways, so how to set up alias, how kube config view, multiple kube configs, and then listing the API resources. Let's say you don't know how to list what are the options available. If you have uh, set up the auto completion, okay, for example, kubectl, and say double tap, you see it is showing me everything that is available with the kubectl. Okay, so I don't really need to remember everything. All I need to know is a little bit of what that command does. For example, if you see here, he mentioned list all API resources. So kubectl, and then you are doing tab only, right? If I say kubectl API resources, it listed resources. Hold on, I'm trying to reduce the size just to kind of trying to fit in one screen. Okay, all right. I think it looks much better. And if you run it, it tells you there is a resource named bindings. And let me make it here so that it doesn't cut in the video. All right, so bindings, there is component status. All these are different APIs that are available in Kubernetes. Anyways, we are not getting into it yet. And next is client certificate, kubelet, um, user authentication, and few other things, right? Now, in Kubernetes, all the components, when they talk to each other, let's see, first of all, Kubernetes component, how do they work, right? So this is kind of a refresher on what I did last time. So you have one control plane, and then you have nodes. On control plane, you're running, at least 4 or 5 components. API is the main, I would say, brain of it, and HCD is the heart of it. Everything is stored in HCD. API is used to access whenever you are running kubectl command. They connect to API server. API server is talking to all other components. Scheduler ensures where pod goes. Kubelet runs that pod. Kproxy or kubeproxy is responsible for your network connectivity. Then you have control loops, and you have we call it controller manager, and there is CCM, cloud controller manager. It is it allows cloud service providers to deploy their specific components, or specific API, or extend Kubernetes, I would say. Right. All right. So with this, I think what I wanted to kind of show you with this is whenever API need to talk to CCM, or API need to talk with the CM, controller manager, or scheduler, or HCD, this communication between these, it happens on uh, secure ports. There are certificates that get validated, so that is why in Chad's repository we see it talks about PKI is public key infrastructure, right? Then there are nodes. Kubelets are talking to API. If kubelet doesn't basically trust the certificate, CA certificate of API, it'll not be able to connect to this. And similar story, if this guy doesn't have a certificate that was created with the API CA, it will not be able to connect. So you see all these components, when they talk to API server, or maybe if they need to talk to each other also, just in case, in those cases they need something which can ensure that source and destination are secure, and that happens with the help of public key infrastructure, and we call that PKI. Okay. All right, so with that, I'll get back to what chat was showing. Okay, he says in Varlab kubelet PKI you have your certificates, right? So because it says kubelet, this tells you he's talking about a client machine. Why? Because we saw it here. You see, every node where your workloads run, they have something called kubelet. You see here, they have kubelet. So just by looking at it, I can see, or I can say that he's talking about a client node without even reading what he has written on top, right? But anyways, let's look into our cluster, right? So we installed a cluster with the multi-pass. Let's see if it is running. Okay, multi-pass uh, shell cube master. Let's see if I can get into it. Okay, all right. So I'm in cube master. Now in cube master, we should have some containers running, right? Those containers are responsible for API server, controller manager, scheduler, even your etcd, right? So where does kind of Kubernetes deploy all these, or what is the default location, if I may, right? So let's see, I'm going to increase the size. So go into etc, and then you have a directory called Kubernetes. So in this directory, in etc Kubernetes, first thing you see is PKI. So let's go into PKI and see what we have. We have a CA key, we have a CA cert. This is your cluster CA certification authority. Um, this is certificate for that. And this CA creates and signs certificates for all other components. Before I get into kind of deeper into the certificates, let's look at other components. There is a API server key, API server certificate, then API server kubelet client. Anybody who connects to kubelet using a certificate, right? This is that kind of certificate, right? Kubelet client. Then your front proxy client, and your front proxy, your API. This, I think we use it for your web interface, but I'll look into it later. I'll share a bit more details on it. Then these are your service account key, and yeah, and then you have HCD client key, and HCD client cert. Now HCD has its own CA. If I go in HCD, and you'll see it has its own CA, CA.cert, server key, peer key. So peer and peer key, this helps if you have more than one HCD server and they are in kind of replicating with each other. You need peer keys. That's where these two, peer key and peer cert, comes into picture. Then if you have a node that is doing health checks, this is these are certificate for that. Anyways, main certificates are your CA certificates and your server key and certificate. This is your HCD CA and certificates for that. The previous directory had CA, that is for your Kubernetes. And with that, I get out of it, and we have admin.conf, which is kind of main configuration file you use to connect with your Kubernetes. It is basically something similar or 100% same as your kubectl or kubeconf, right? In the home directory, we saw dot cube and then slash config file. It is something similar. When you are into this system, you can do this, cat admin.conf to see the content of it. I'm not gonna do it. You have super admin, controller manager, scheduler, and kubelet. Uh, these are some files that you use to kind of manage your cluster. But if you go in manifest, you'll see few things which are very important for your cluster. First is HCD. If you look at it, it is a pod definition. You see, this is what tells you what it is. In the beginning, it says kind pod. It's a pod definition, and what pod it is, you can see here, it says HCD, right? And it name also tells you it is HCD pod, right? And there are a lot of details provided about HCD, how it works. And similarly, you have Cube API server. So you are looking at here, it is pod. All these files, these are called static pods. Anything that you are placing in this directory with the .yaml, your kubelet running on this node is keeping an eye on it, and it spins up as a container, and that container uniform helps to form your Kubernetes cluster. That's how it works. But anyways, all right, so your Kube API server is here. It says where to advertise, or who should, or on what IP address people should be able to connect to it, where should it go and connect to HCD server. All these options that you see here, you should know a bit about them, right? During exam, they might mess up this HCD server, and instead of HTTPS, they might say HTTPX, right? So just one character change, and your API server will not start. Or they'll say extend it, add a new option, right? So we'll look into those things, but this is one of the topics where you need to go and troubleshoot things, right? So knowing where these files are is very important. Knowing what different settings are available for each of these components is very important, right? So with that, I think I have about 30 minutes video, and all right. Before I end, I wanted to show you few more things, which is, for example, these are just tips and tricks that can help you to be better during the exam. K run, K is kubectl, nothing special, right? Run test, then you specify this is test is name of a pod. When you say run, that means you are asking it to run a pod. If you say k create means it will go and create a deployment. If you say k run, it is creating a pod. Test, then you give it some image, busy box, and hyphen hyphen image, busy box, and hyphen hyphen command, while true, do echo hello from busy box, done. And you can see it says pod creator. But what if I didn't want to do this? What if I created it and it is not able to run? For example, let's see, right? K logs, and I want to see what it is doing. Oh, looks like we didn't do the right thing. Looks like it failed as I was expecting, right? K describe, and if we see there, It says back off, restarting field container. You can see void field, right? So this is called events. This is one of the thing that you use while you are troubleshooting, right? So you can do kget events, and you can either you can do this or okay. So for must be for test. Right now, what is the difference between kget events between this command and this command? The difference is when you run kget events, it is running against your default namespace and pulling all the events from that namespace. If you have 1,000 events because you have, you know, 100 containers running, it'll show events for everything, and that makes our life difficult to figure out, you know, what container it happened for. One way to do is, you know, you run kget events, then you kind of grep for it, right? That's a messy way of doing things. Why I say messy? Because you are pulling 1,000 like, events for 1,000 containers if there are 1,000 running, right? You don't need to. You can target it for a particular resource. For example, in this case, I said pods and slash test, right? So now you are pulling events only for particular container, not for 1,000 resources, right? So remember, your API is also using some resources. You don't want to put more burden on API to give you data which you don't need. Basically, you're discarding by using a grep later in the output, right? Rather than you do it like this: k events for pods test. Now you are getting events for a particular pod only. Okay, now let's read it. What happened when I ran that command? It Our scheduler looked at it and he said, you know, in default test namespace or test pod, I'm going to assign it to kube worker 2. I have enough resources there. Then said, okay, looks like this guy wants busybox image, because remember we mentioned hyphen hyphen image busybox, right? Now it is downloading the pieces of busybox image. Finally the image got downloaded, container created, but container failed to start. Why? Because the command which I mentioned, right, that command couldn't run because it says file not found, hello from busybox file not found. Okay, so it means I did not supply the command right, and that's why it failed. So that was kind of a demonstration of how you can see what happened when you try to run a container and it failed. How do you kind of interpret all these logs for a particular type of object only? For example, in this case, we ran it for a pod. Okay. You can also do k describe, and then you can do pods and test, right? So I can do pods and test. Now this gives you a different kind of view. It also tells you what service account was used, what node it was running on, what labels it assigned. Then it says do hello, or what command did I run, and it's a waiting run container error. You from here you can understand that this container did not run successfully. But here it says state running. It should be running, but it terminated because the start command or the command that I passed on command line, that failed. That's why it says in a run command, run container error. Yeah, so you can see all the status related details here, whether it was initialized properly or not, whether container is ready or not. right? So all these details are here. Then finally, in the end, you see the events too. It is something similar to what we saw earlier, right? And with that, before I close, just one last command. Um, for example, when I created this container, I provided one command, but that command didn't work, right? So, what can I do rather than sending commands directly to my Kubernetes cluster and creating something which doesn't work? What can I do? Uh, we can do -o YAML, and somewhere here we can say hyphen dry run equal to client. So if you do that, what is the difference? This time it didn't try to go and run this container. It created the pod definition and it gave me the output. And this output I can literally send it to a file, and I can do a greater than sign, which is a redirect, output redirect to a file, and then modify that file, make sure everything is correct inside that. And with that, um, once my pod definition is correct, I can go and just run the container. I can say kubectl create -f and the file name, right? Or I can say kubectl apply -f and the file name that I just created. All right. This was a very high level overview of containers. This time we, trying to kind of summarize what we did. We looked at CKA exam, the requirements, a repository which has some commands, some details available about, how much percentage comes from which section. After that, we looked into our cube config file. We looked at cube config variable too. We logged into our master, looked at our different certificates, our PKI infrastructure, public key infrastructure. We understood what the CA certs are for our API, and we also looked at CA certs and other configurations for our etcd. We looked at static pods that are used for etcd API, your controller manager scheduler. They are generally placed in, etc on your master node. Log into master node inside etc Kubernetes manifest. You'll find them there. We again reviewed architecture of Kubernetes, and once we were done with that, we ran a test container. We made sure it fails. We looked at events for that particular container. We looked at events for everything inside namespace. Then we looked at events for a very particular container rather than kind of pulling everything. We also looked at documentation, how to go and find the right documentation, and how to create your YAML file imperatively. The command you see on your screen, this command, the way I'm running here with the dry run -o YAML, this is called imperative way of creating your YAML files. Once you have YAML file, you go modify, make all the changes you need, you say kubectl apply, and you have a working pod. All right, with that, I'm going to close. Uh, Next week, I'll have some YAML files ready. Sorry, not next week, next to next week. Next week, I'm recording something for our beginners. All right, with that, I'll close. Have a good one. Take care. Thank you. Bye.